In this section, we're going to take a look at engine governors. We're going to look at how they work on an engine, what they're doing for us on the engine, different mechanisms, and so forth. Now, we've already been talking about governors on and off in different ways as we've gone through this course. And specifically, when we looked at the engine performance in these torque speed curves, we've talked about what the governor does on an engine. Specifically, we talked about on the far side, on the right-hand side of this curve, where we would, when we were testing our engines, we would set that engine at a certain speed, maybe at the maximum speed. And then we would start to load that engine, and as we loaded that engine, the torque would go up, we'd get some load, and we would see the speed drop a little bit, but that governor in this part of the curve is trying to control that engine speed. It's trying to keep that engine at a good speed, at a constant speed. So the slower, the more load there is, the engine starts to slow down, the governor is going to open up whatever the engine control is. So maybe the throttle plate in a carburetor, it might be opening the injector pump on a compression ignition engine, whatever it needs to do to send more power to the engine to say, hey, it's slowing down, let's try to keep it at the maximum speed. So that's what the governors do. And so when we look at the function of a governor, the main function is to maintain the speed of an engine. Now, I will mention at this point that not all engines have a governor on them. So not all engines need to maintain the speed in and of themselves. So a good example of an engine that does not necessarily need a governor is a chainsaw down here. So a chainsaw, the operator is what's going to control the speed of that chainsaw. So most of the time when we operate a chainsaw, we hold it wide open and let it cut as fast as it can go. If we do want to go slow, getting to the end of a cut or something like that, the operator will control that speed with their finger and let it slow down. So it's not like I'm going to set a minimum speed or a lower speed and then hope that the governor is going to compensate and keep that thing at a constant speed. I just let it go and I control the speed. Your automobile is the same way. And motorcycles, they don't necessarily have governors on it. You control it with the speed. So as you start up a hill, you push the gas pedal down a little bit more or open that throttle on the motorcycle a little bit more to be able to maintain that speed. So you as the operator are acting as the governor. So you're kind of maintaining that function. But now, some of our engines, like a lawnmower, for instance, I want that thing to maintain speed. So I'm going to set that thing at a typical speed, maybe at its maximum speed, maybe not quite at its maximum speed, and I'm going to start mowing my grass. And when I come to a big clump of grass, I want that engine to stay operating at a pretty constant speed, hopefully. So when I hit that clump of grass, I want that governor to start to compensate, to speed that, to keep that engine from slowing down too much. Then when I get out of it, I don't want the engine to overspeed, so I want the governor to shut that control down, slow that engine back down a little bit. And so those kind of engines will have governors on them. So lawnmowers, tractors, different things like applications like that, where I want that engine running at constant speed, they're going to have a governor. And again, that's the main purpose of a governor, is just to maintain a speed setting on that engine, whatever it be. So maybe it's just a constant speed or a maximum speed. Maybe it's something that I can change with some type of a throttle control or something like that, like I can do on a tractor. So that's the main function. The second function of a governor is that it limits the maximum speed. And this is kind of by de facto. So if I have a maximum speed that I can set that engine to, the governor is not going to let that engine go above that speed. So it's kind of a protection mechanism for the engine. So it keeps it from overspeeding, keep the engine from damaging itself. And so that's the second function of it. And again, that's not necessarily a specific different thing, but it's just something that kind of naturally happens because that governor is maintaining the speed of the engine. Now, your textbook actually lists 3 different functions of a governor, and they talk about limiting both high and low speed. And here's where I'm going to take a little bit of a disagreement with what your textbook says there. And I'll come back and talk about this a little bit more because they give an indication that it limits the low speed. Now, certainly it limits the high speed, keeps the engine from overspeeding, but the governor really doesn't limit an idle speed. This kind of gives you the indication that at low idle, so when I get to a traffic light with my car and let off the gas, that it indicates that the governor is controlling that low speed. And that's not always the case. especially on our small gas engines, as we'll look at, that the governor really doesn't have anything to do with that low speed. And we'll talk about that. We'll come back and look at that mechanism and how we control that. So again, I take a little bit of a different opinion, a bit of a disagreement with what your textbook has on that. But the important thing is the two functions up here. The main function is maintains the speed of the engine. The second function is that it limits the maximum speed, so it keeps the engine from overspeeding. So those are the two functions of it. Now, there's two different types of governors. And we will spend some time looking at the mechanical type governors. So it's just a mechanical mechanism. These are simpler, relatively inexpensive mechanisms that we're going to see on typically on smaller engines nowadays, or on a lot of older engine technology. A lot of our newer engines and larger engines are going to electronic type governors, where everything's done electronically. So we put a sensor that senses the speed of the crankshaft. That sensor feeds into a little computer. The computer makes some decision about whether the engine's going too fast or too slow, and then it sends a signal to some other kind of an electronic actuator that's going to try to speed up or slow down that engine, control the input on the engine. And so that's all done electronically. But a lot of our engines, again, a lot of our small engines, even newer small engines, still use these mechanical type governors. So we're going to spend some time looking at those, and let's dig back a little bit in history to try to get our head wrapped around how a governor works and what it's doing. So looking at the mechanism. So we're going to look at a centrifugal type governor, and we're going to go to, again, to history, look at old technology. We're going to see a steam engine here in a second that utilizes this technology. So one of the first type of governors that were developed was what's called a flyball governor. And a flyball is basically weights that I'm going to spin around, kind of like spinning a weight on a rope or something like that. Let that thing spin. And the faster I spin it, the harder that centripetal force is, the more that force wants that weight to fly away from the center. Okay, so you can see in this animation here, I've got that weight spinning. So this is kind of what the mechanism looks like over here, where I have two weights so that it's balanced. The anchor point up here is fixed, but this collar down here is able to slide up and down on this shaft. So as I spin this thing, and as I spin it faster, I get more and more centripetal force. These two balls try to fly out. And as they fly out, this is kind of like a scissor mechanism here. So as they fly out, it's going to pull this collar up on the shaft. As it slows down, this collar is going to go back down. And in the animation, you can kind of see this lower collar sliding up and down a little bit. So there's a little bit of movement there. Okay, now what we do then, this collar as it slides, we're going to connect that to some linkage that controls the speed of the engine. So this becomes a balancing act. So as the engine goes faster, these fly balls will go out. It pulls this collar up. That's going to activate something on the engine to slow the engine down. So as the engine slows down, if it slows down too much, those balls come in too far, this collar slides too far down, that's going to be connected to whatever's controlling the engine. It's going to try to speed the engine back up, send some more power to it. So it becomes, again, it's a balancing act. So we get it to the right point where these balls are flying at the place where we want them to, then we maintain the speed of that engine. So that's the concept. What we do, centripetal force, just these balls flying around. I'll show you a picture of one of these, and actually this is a photograph that I took only a couple years ago. This is actually a sugarcane processing facility in Brazil where they were actually using a steam engine. So you see the steam engine here, great big flywheel, connecting rod here, and a piston that's going in and out. So they're creating heat by burning sugarcane bagasse, or the leftovers from the sugarcane processing. It's free fuel, so they burn it, create steam, and they've got this steam engine that's working here. Well, to control the speed of that steam engine, they have a flyball governor. It sits right up here on top, and you can see the balls. Here's a close-up of that flyball governor right here. This one actually has 3 different balls on it. So as that spins, and it will spin because there's gears on the bottom of it that are connected to shafts that are connected to the crankshaft of that steam engine. So the faster that steam engine spins, the more these balls go out. So they're flying out, they go out. And again, that scissor mechanism, and on this particular mechanism, the bottom is fixed because that's where the gear is. but the top is going to move up and down. So the top of this thing will move up and down. The shaft that goes through there goes down into here, and right in this area is a steam valve. And so what happens is the faster this engine goes, the more those balls go out. That's going to pull this shaft down. It's going to push down into the steam valve, and it's going to shut the steam off and let less steam go into the engine to keep the engine from going too fast. Then when I start putting that sugar cane in there and start pressing it and it needs more load, that engine's going to slow down a little bit. The balls are going to come in. That's going to pull that shaft up, and that's going to allow more steam to go through. So it's going to open up that hole, allow more steam to get more power to that engine so that it can maintain its speed. So fairly simple mechanism. And that's the basic concept of a mechanical centrifugal type of a governor. So again, we'll go to some older technology here, some antique engine technology. And so here's an old engine, internal combustion engine. There's a flyball governor. You can see it right out in the open there that it's spinning. And nothing's covered up on these things, so it's not very safe. But you can see the flyball governor spinning. And this is kind of what the mechanism would look like or how it works on that. So the flyball governor is spinning out there. So you can see this collar moves up and down as the engine speeds up and slows down. As the collar moves down, the balls fly out, pulls the collar down. You look at how that mechanism is connected to the throttle plate on the carburetor, and as the engine speeds up, the shaft comes up, it closes that throttle plate, and it slows the engine down, so it's maintaining the speed. As the engine goes too slow, that lets the collar go back up, it opens that throttle plate, let more fuel go in. So we're controlling the speed of that engine, and again, this would be like on a carburetor, controlling how much of that air-fuel mixture we're allowing into that engine based on how fast those balls are going. Now, the next thing we're going to look at is actually dig into the mechanisms in a small gas engine, because this is kind of set up for a constant speed. What if I want to change the speed setting of the engine? How do I do that? So that's what we're going to take a look at next.